In this video, we're going to do a example or a walkthrough of a weak base strong acid titration. So for that, we're going to have to consider the titration of 0.165 molar methylamine with 0.15 molar hydrobromic acid. So the first question is, how much HBr is needed? Secondly, what is the initial pH of this solution? What is the pH after adding just 10 mils of HBr? What is the pH at the equivalence point? And what is the pH after adding 30 mils of HBr? So we're going to answer all of these questions based on this titration. So the first question is how much HBr is needed. So what we're going to do is simple stoichiometry. So we're starting with 0.165 moles of methylamine per liter, right? That's our molarity. And we've got 0.0220 liters of it. And there's a 1-to-1 mole ratio in this reaction like there are in many acid-base reactions. So a mole and a mole. Our methylamine is here. Our HBr is here. And we have 0.150 moles of HBr per liter. When we do that math, we come out with 0.0242 liters, which is the same as 24.2 milliliters. So that answers that part of the question. Now we want to know what the initial pH is. So here's our reaction. Our methylamine is in water, and it goes to, it's acting like a base, remember? So it makes this, and we have OH minus. So what we're gonna get is the concentration of OH minus. So the concentration of this that we're starting with is 0.165 molar. We've got none of this, none of this. Some of this goes away, some of this gets formed. So we're gonna have, this is our equilibrium amount from our ice table. And when we set this up, x squared over 0.165 minus x, that's gonna be equal to our Kb for this stuff, which when we look it up has a value of 4.4 times 10 to the minus 4. Okay, so we can make our small x approximation. So x squared over 0.165 is 4.4 times 10 to the minus 4. And when we solve this for x, goes through a couple of other steps, we get an x value of 0.00852 molar. And remember, that is our concentration of OH minus. So when we take the negative log of that, we get a pOH of 2.07. We're interested in the pH. So to get the pH, we subtract that from 14, and we get 11.93. So that is our pH at the start of this. So now our question is, what's the pH after adding 10 mils of HBr? So let's remember, this is our methylamine. And we're adding to it our acid, and we're going to end up getting this. Remember, this is our base, and this is an acid, and that's going to be important when we use the Henderson-Hasselbalch equation. So, in terms of moles that we're starting with, we are starting with a 0.165 molar solution of this, and we've got 22 milliliters of it, and we're adding a 0.15 molar solution of HBr, and we're adding 10 mils of it, 0.010 molar. Okay, this is in lesser amount, so it's all going to react. So all this goes away, and it takes some of this with it, specifically this much. Okay. This goes down to 0. That's going to go to some other number, and we end up making some of this. Okay, so when we do this math, we get 0.00213 moles of our base and 0.00150 moles of our acid. So this is sort of our HA, and this is our A minus for the Henderson-Hasselbalch. So what we also need is the Ka for this to use our Henderson-Hasselbalch. There's our Henderson-Hasselbalch equation. Okay, so we need the pKa of our base. So we got to get the Ka. So the Ka is equal to our Kw over our Kb. So 1.0 times 10 to the minus 14 over 4.4 times 10 to the minus 4. And that gives us 2.27 times 10 to the minus 11. If we take the negative log of that, our pKa is 10.64. Okay, so our pH is 10.64 plus the log of our acid, sorry, our base, 0.00213 over our acid, 0.00150. Run that through our calculator and we get 10.79. That is a lower pH than what we started with, and that should make sense because we've added some acid. So now the question is, what is the pH at the equivalence point? So let's remember, if this is what we were starting with, this is our methylamine, NH2, and we were adding H plus to it, then we've made our cation on this side. And at the equivalence point, this is all we have. We've run out of this. So our actual equilibrium is looking a little more like this. Okay, and we're going to try and get the concentration of this to get our pH. So at the equivalence point, this is the only thing we have, and we got that by adding all of what we needed. And all the moles that we used was 0.150 molar, because that was our HBr. And we ended up adding 0.0242 milliliters of it. Okay, so that tells us the number of moles that we have. However, what we're really interested in is the concentration. So we started with a volume of 0.0242 for our acid and 0.0220 for our base. So that's the volume of our acid and base, and this is the number of moles that we end up having of this. When we do that math, we get 0.07857, and that's the molarity of the stuff that we have there. Okay, so I'll rewrite this equation here just to be neat. And we've got this concentration initially. None of this, none of this. Some of this goes away, some of this forms. I've got x and x, 0.07857 minus x. Setting this up and doing our small x approximation. This is going to be equal to the to the Ka, and we calculated that before, and that was 2.27 times 10 to the minus 11. So when we go through and we solve for this, we get an x that has a value of 1.336 times 10 to the minus 6, and our pH is 5.87. It's less than 7. This is acidic, and that should make sense because at the equivalence point, the only thing we have is the conjugate acid of a weak base, which means it's acting like an acid, so we should have an acidic pH at the equivalence point. Our final question here is, what is the pH after adding 30 mils of HBr? So this is beyond the amount that we needed. So here is our regular equation. And the amount that I started with in terms of moles was 0.165, and I started with 0.220 liters of this stuff, and I end up adding 0.150 molar solution of H+, and I add 30 milliliters of it. Okay, I don't really care about this stuff right now. Now this is what I have in larger amount, this is what I have in smaller amount, so all of this reacts. So all of these moles go away. And take some of this with it, but not all of it. This amount comes out to 0, and this amount here is going to come out to 8.7 times 10 to the minus 4 moles of H+. And in order for me to get the pH, I need the concentration, not the mole. So I need to know the volume that's here. So 8.7 times 10 to the minus 4 moles over the volume, which was 0.0220 of the base initially, and I added 30 mils of acid, 0.030 liters of the acid, and that gets me to a concentration, which comes out to 0.01673 molar, and that's the concentration of my acid. This is excess acid. So what's my pH? It's the negative log of that, and that comes out to 1.78. So it should be a fairly acidic pH because I've titrated my base completely and I have nothing but leftover acid. So that is pretty much it. Good luck with your problem.